Hi, good afternoon, everyone. We're going to get started. Thank you again for joining us. My name is Bibas Bhattacharya, and for last 2 years, I've been working with AngularJS, helping a couple of large companies implement various features in their website. So I've been with this for a while and quite excited about this Angular 2 coming out. Right now, it's in beta, as you might know. So today's objective is to just have a gentle introduction into Angular 2. We're not going to get into too much depth, but just take a look at it at a high level and get an understanding of what it is, why do we care about Angular 2, and how can we get started. That's basically the objective here. And so the way we do these webinars is that feel free to ask questions at any time. There is a questions pane in GoToWebinar. You can ask questions, and I'll see it popping up on my end, and I'll do my best to answer your questions right away. We'll also have a question and answer session at the end, probably about 10 minutes or so. And you can also wait for the Q&A session to ask questions. It's up to you. Okay. Let's get started. So what is Angular 2? Angular 2 is basically, you can call it the next version if you want, or next iteration of AngularJS. We don't call it AngularJS 2, we call it Angular 2. So the name has been shortened. Like before, Angular 2 is still funded mainly by Google. Most of the full-time employees are from Google. It is an open source project, but there are people working on it full-time, and they're all Google employees. One big difference now is that the preferred programming language for Angular 2 is TypeScript, and we're going to spend quite a bit of time today talking about TypeScript. In addition to TypeScript, you can also program in ES6, which is JavaScript 2015, I'm sorry. You can also program in Dart, but Google's Dart programming language is pretty much at a dead end right now. There's not much going on, so I don't think Dart is something you're going to be considering at this point. Having said all that, though, it's quite clear that the preferred programming language for Angular 2 is TypeScript, and we'll see why. So the website for Angular 2 is angular.io, so it's a new website. And I have also put the GitHub repository. You can go take a look at it. Sometimes I find myself searching through their source code to get a better understanding of things. And you can also do the same thing. So here I have listed in why Angular 2. Oh, by the way, I have posted the PDF of the slides in the handouts pane, so you can actually download the PDF, the same one I'm using here, and you can follow through with me, or you can just look at my screen. It's up to you. But the slides are available in the handouts pane of GoToWebinar. Okay, so here in this slide, I just listed a few items about what are the advantages of Angular 2, why do we care, why you should consider moving to Angular 2. So there I find the most appealing story about Angular 2 is something called components. And we'll obviously take a look at components in more details later on. A component is a self-contained artifact or piece of code that does everything. It will render data. It will display data to the user in whatever form, text, images, and whatnot. It will also accept user inputs. It will deal with the user input handling. So it does everything. And it can be easily added to a page with just a tag. So think of components like widgets in GUI development or desktop development. So you can develop components and consume them very quickly and easily. Then we have something called server-side rendering of a page. Until now, with Angular 1, all the page rendering was done in the client side, which is cool, nothing wrong with that. There was one problem with that, though. The search engine optimization was not so good in Angular 1, because when Google or any other search engine crawled through your site, all they found was the static HTML with all the Angular handlebar mustache template code, which they didn't evaluate, obviously. So the content did not show up in these pages, and your pages probably had a poor search engine ranking because of that. So this problem now can be solved by pre-rendering the page, or at least the first view of the page as it appears from the server side. And so it increases the search engine optimization ranking, as well as it has some performance advantages. By the way, Angular 2 in general is more performant than Angular 1. They made several changes in various areas where Angular 2 will perform better than Angular 1. And one of the ways is by pre-rendering the page in the server side. Today, we're not going to get into too much details about how to do server-side rendering. We just don't have time for it. One thing to keep in mind is if you are excited about server-side rendering, considering using it, you have to be aware that it requires some special hookup with your server-side technology. So, for example, if you're using Java or .NET, or whatever your server-side technology is, it's going to require some additional plugins to be installed there and enabled. Okay, so that your server-side can render pages that you are developing using Angular. Not all server-side platforms are supported. Java itself was supported only like a week or so ago, not very recently. So Google is adding more and more support. But if you're using something like Python or whatever, make sure that Angular has plans to support that server platform. I'm going to move on. I'm not going to discuss server-side rendering anything beyond that at this point. Okay. So third bullet point here is that in Angular 1, you probably used Angular's module construct. You created a module and you defined controllers and services within that module. In Angular 2, there is no such concept as a module. Instead, what we are getting is the module syntax or module system for ES6. So JavaScript now has its own module system, which is pretty cool and well thought out. So instead of coming up with its own module system, Angular simply decided to use the module system of ES6, and we'll take a look at again how to use it. So some of the advantages there are that if your application code, or if your Angular code is split up in, say, multiple different files, 10 or 20 files. In Angular 1, you had to carefully include all of those JavaScript files in every HTML page. So the ordering was important. You have to be careful about that, and you have to very much include all of them. And now with the ES6 module system, you don't have to do that anymore. Each module pulls in any other module that it depends on. So it dynamically, there's a dependency trees built, and only the code that gets used in a page will be downloaded, nothing else. And you don't have to worry about ordering and things like that. The whole dependency is taken care of for you, which for a large project saves a lot of trouble. And also we're getting namespacing. So every module has private variables and functions and things like that. And all the exported methods and variables are also defined within the namespace of the module. So that's another problem that's taken care of by ES6 module system. And next we have, as I said earlier, that the preferred programming language for Angular 2 is TypeScript. And again, we'll take a look at it in the next few slides. But what TypeScript gives you is a very strongly typed programming language. So like C# or Java or C++, it is a strongly typed language which is one of the weaknesses of plain JavaScript. It's not strongly typed. And so for a large and complex project, that becomes a problem. Refactoring code becomes a problem, or if you have certain type safety issues in your code that only shows up at runtime. For example, you're accessing a property that doesn't exist, will only show up at runtime, and debugging them can be difficult sometimes. And whereas with a type-safe programming language, these problems will be checked by the compiler, and you'll know right away that there is a problem. Another thing is the service development has been simplified. With Angular 1, there was unnecessarily, there are different ways of creating a service. Like you could create a factory, you could create a service, you could create a provider. They all pretty much did the same thing. And we'll see how this has been simplified in Angular 2. And there are a whole bunch of other benefits as well, but these are something you need to know right off the bat. Okay, so what we're going to do now is we're going to spend a little bit of time talking about TypeScript. This might be a new programming language for you. So before you get into learning Angular 2, make sure you have a good understanding about TypeScript, because otherwise when you look at the tutorials and documents and examples, you'll have unnecessary difficulty. You don't want to learn two things at the same time. So first learn TypeScript a little bit, and then you can tackle Angular 2. Otherwise you'll be unnecessarily frustrated. So that's one of the reasons I wanted to talk about TypeScript first. Hopefully this presentation itself will be enough for you to know enough TypeScript so you can kind of jump into Angular 2 after this. So what is TypeScript? It is a strongly typed programming language like C#, Java. Every variable has type. The methods have arguments that have types. Method return types have types. So everything is strongly typed. The expectation is that the compiler would catch most of the type problems at compile time, and you don't have to worry about you don't have to wait for the problems to pop up at runtime, which is the case for a regular JavaScript program. So right now, the TypeScript compiler will transpile your TypeScript code into ES5, which is the most widely supported JavaScript in the browsers today. So we don't have to worry about it. The TypeScript is not natively supported by any browser, but the compiler is going to convert your code or transpile your code into ES5, which is widely supported by the browsers. TypeScript has object-oriented notations like classes, inheritance, interface, things like that. So if you are a Java programmer or a C# programmer, you should be able to learn TypeScript quite easily because they're very similar in nature. As I said earlier, you could also write Angular 2 code using ES6, which also has object-oriented programming syntax. Unfortunately, ES6 is very poorly supported today by the browsers. Even the cutting-edge browsers like Chrome has very little support for ES6. So if you decide to use ES6, you still have to transpile. You cannot get away with transpiling. So it's the basic logic here is that if you are transpiling, might as well use TypeScript because it gives you strong type safety. And also it's worth noting that Angular 2 itself is developed using TypeScript. So in all possible respect, TypeScript seems to be the preferred programming language. So what is really cool about TypeScript is, which is what I discuss in the next slide, is that it's not a totally foreign language. It's not something completely out of the blue. TypeScript is a superset of the JavaScript that you know and love already. Okay, it builds on top of the JavaScript programming language. So at the core, you have ES5, which has been there for years. So we have ES5. On top of that, we have ES6, which just came out last year. It's ratified and is formally released, but not widely supported by the browsers. So ES6 is adding The module syntax, which is what we're going to take a look at later. It's adding classes and interfaces. In other words, the object orientation is getting added by ES6. On top of ES6, we have ES7 down the pipeline that's being worked on right now. ES7, I think ES7 is adding some type safety on that on ES6. On top of ES7, we are adding more type safety, and that's what we call the TypeScript programming language. So TypeScript is built on top of ES5, 6, and 7 by adding some more extra spice to the programming language, and that's when you get TypeScript. So the advantage of this decision or this design decision that the TypeScript developers took, there are some advantages to that. It's easy for you to learn the language because a lot of it is going to be plain JavaScript at the core. And then you can use your legacy JavaScript code. For example, you can use jQuery. You can use any JavaScript code that you have developed. It's readily available and usable because all JavaScript code is valid TypeScript code. And as you are learning TypeScript, effectively you're also learning ES6 in many ways. So things like module, classes, and interfaces, all of that you're learning. And if you ever have to work on a project which is ES6, like for example, you might be working on a Node.js project, a Node server-side or some kind of a desktop application. I do a lot of desktop application using Node, and I find myself using a lot of ES6 there. And so your the TypeScript knowledge becomes transferable to ES6 as well. So there's a lot of advantages there. Okay. Now we take a look at the class and the module syntax of TypeScript in the next slide. So we have a class called customer, and we define it by saying export class customer. Export means it's a public class that's visible and usable by code from outside of this module. Okay, so this class has been defined in a file called cust.ts. Okay. And the module name is the same as the file name, which is cust. Cust is our module name. Within that file, we have defined a class called customer. Okay, and these keywords like export and class, they are not something that TypeScript came up with. These are ES6 syntax. And as I said, TypeScript builds on top of ES6, so we inherit all these keywords. What TypeScript is adding, however, here is the type safety. So you notice there, the customer has two fields, customer ID and full name. There we have defined the data type of these fields. Customer ID is a number, full name is a string. So that type safety or the type declaration is something that's coming from TypeScript. Everything else is plain JavaScript or ES6. Including the constructor keyword, which is by defining a constructor, that's also ES6. Nothing new there. However, look at the constructor's argument list. We are saying that the ID argument is a number, name is a string. That type declaration, and once again, is coming from TypeScript. And the class has a method called printed, which simply is printing out some kind of a debug statement about the customer. Notice the backtick there. It's not a typo. ES6 has added a templated string or formatted string, if you want to call that, and that has a backtick instead of a single quote or a double quote. And once you have a backtick string, you can put variables within that using the dollar curly brace syntax, which is going to be embedded into the string. So that's again ES6. Any questions about the class declaration or TypeScript? It should be pretty obvious to you. Take a look at it. If you have any question, you can ask anytime. What I'm going to do now is I'm going to show you Okay, somebody has asked a question. Does TypeScript have private members? Yes, it does. Yes, it does. I don't show you how to do that, but it is possible to have a private member and public member. You can control the visibility. Yes. Okay, next slide, I'm showing how to use the class I have defined. So remember, the class was defined in a file called cust.ts. So first thing I got to do is I got to import the class. I got to bring the name customer, which is the name of the class, into the scope. The name has to be visible within the scope of my current code. So I do import, and I'm only importing customer, so I can pick and choose what class, what method, what data I want to import. I don't have to import everything, or I can choose to import everything. It's up to me. The more picky you are, the more carefully you pick and choose what you want to import. Obviously your code is going to be more efficient. If you're not sure if you are going to be using almost everything, just import everything. In that case, the syntax is slightly different. Again, I don't show you here how to do that. But in this particular case, I'm only importing the customer class name from the module called cust. All right. So one of the crucial things is going to happen at this point when the interpreter goes to the import statement is that it's going to actually pull in the JavaScript from cust.js dynamically. So this is what I was talking about. Modules can depend on other modules. And this dependency is built using the import statement. Your HTML file doesn't have to include all the JavaScript files. The JavaScript files will be fetched over the network on demand based on the dependency that's created using the import statement. All right, that's enough about import. Once again, it's a ES6 thing. It's not something that's coming from TypeScript. We're simply using it from TypeScript. So once we bring in the name customer into the namespace, we can create an object of that class. We call varc equals new customer, and here we are calling a constructor. All of this will be type checked by the compiler if you have any kind of a type mismatch. So for example, for the second argument, instead of supplying a string, if you supply a number, that's going to be a compiler. You're going to get to see that right away. And once you create the class, once you create the object, you can start calling its public methods and access its public variables, public fields. And the last line, we are calling a method called say hello, but guess what? There is no method called say hello in the customer class, so the compiler is going to catch that and give you a compiler. And one of the cool things is, I don't know if it's a cool thing or not, but something you should know is that the TypeScript compiler is going to go ahead and compile it. It's going to give you the error message, but it's going to generate the JavaScript file anyways. It's going to create the transpiled JavaScript file with this problem anyways. So you can decide to ignore the error and go ahead and deploy the transpiled JavaScript code. Then what's going to happen? You're going to see this when that line executes at runtime. You're going to get a runtime error. So it's a compile time as well as a runtime error, but chances are high that you're going to pay attention to the compiler error and not deploy this code into production. Which is slightly different from Java or C# or C++. If you have a compiler, you don't get an output. There is no resultant output from the compilation. Here it's a bit different. You still get an output. So keep an eye out for that. Pay attention to that. All right. So now we know how to use a module from another module, how to create a class, how to use the class. Now, it's one thing. So let me go back to the previous slide. It's one thing to bring in another module from within a module using import statement. I'm including the code of the other module using the import statement. Question now is, how do I do that from HTML? At the end of the day, I have to use the JavaScript code from HTML. How do I do that? And there, the issue gets a little bit confusing. Okay, so believe it or not, as it turns out, when they released ES6, they thought about how a module can import another module. That was nailed down, but for some reason they didn't think about how to bring in a module into HTML. It almost seems like an afterthought. I think it was released as a separate spec as well. So anyway, the spec says that you can asynchronously import a module in HTML using the system.import API. So there is an API that you can use to import a module code within HTML, which is a bit of a pain in the neck. You have to write code to import code. We are so used to using the script tag. Now you have to write code. So now people are not happy with that. So now there's a conversation about adding the module tag, which is equivalent to the script tag, but this is to bring in a ES6 module into scope of an HTML. So there is talk about adding the module tag in sometime in the future. Hopefully that happens. When that happens, things will be a lot easier, obviously. Until then, we have system.import. This is formally spec'd out. System.import is the only formally spec'd out way in ES6 to bring in a module into HTML. In future, we might have the module tag. We don't have it today. And as I said earlier, browsers really don't support ES6 all that well. It just came out last year. So for you to use the system.import API, you have to use an open source library called system.js. So system.js kind of mimics or fakes the system.import API, and we're going to be using that to bring in a module. So how do I do that? So I have my usual script tag. There I call system.import, and I supply the path name to the module. Optionally, I can attach two callbacks. The first callback gets called if the module could be loaded and parsed properly. So that's the success handler. And the second callback gets called if there is any kind of problem. For example, the file could not be located in the server. The server returned 404 or whatever. The file could not be located or loaded, or you have some kind of a compilation problem within the JavaScript. You have syntax error. In either of these cases, it's an error condition, and you're going to this error callback is going to get called. It's essential that you register the error callback. Otherwise, if you have compilation problems or any other problem, you're not going to see the error message in the browser's console. It becomes very difficult to debug in that case. So remember, it's not like using the script tag to load a JavaScript file. In that case, you don't have to do anything. In that case, the browser is responsible for showing you the compilation error messages. But here it's different. Here, you have to attach the error callback and print out the error message to know that there is a problem with your JavaScript code, and then so you can debug it. Okay, so this basically boils down to, this slide is all about how do I import a ES6 module from HTML. So this is the approach we are going to take. Okay, so how do I transpile TypeScript code? I believe this is the last slide on TypeScript. So how do I transpile TypeScript code? So remember, a .ts file, which is the TypeScript file, gets compiled into a es5.js file. And at runtime, you use these .js files. You don't use .ts files at runtime. So there are a couple of different approaches. You can use the TypeScript npm module. So you install the TypeScript npm module globally, and that gives you the tsc command or TypeScript compiler command. And you can set tsc file name.ts, and it's going to compile that file, specific file. That's one way of doing it. Or you can run tsc in watch mode, like tsc -w, so it runs in the watch mode from your current directory, or any subdirectory. If it finds any new ts file created or updated, it's going to compile it right away. So it's a real time, it's continuously checking for any changes to your TypeScript code. So that's the way to do it. Option 2, however, I find that it's my favorite, which is to install plugin to your favorite editor like Visual Studio, Atom, anything. The most common editors have TypeScript plugins available. So once you install the plugin, what it does is that as soon as you save a .ts file, right after that, it compiles it right away. And right on the editor, it gives you the error message. So when you click on the error message, it takes you to the line, the usual IDE thing. So I find that a lot more useful, and I get an immediate feedback. I know that I made a mistake, and I can fix it right away. So generally speaking, I'll recommend that. A couple of places that TSC command might be useful is, let's say that you are not checking in the compiled JavaScript files into Git or your version control system. You're only version controlling the TypeScript files. In that case, you probably want to have a build system which builds your code and creates the JavaScript files and then deploys into a test environment or production system and whatnot. So that's where the TSC command becomes useful for. But for day-to-day development, I think the plugins for your editor is probably the better way to go. All right, so that's enough about TypeScript. I think it gave you enough, hopefully it gave you enough idea about TypeScript. So now you can get started with Angular 2. Otherwise, yeah, I have to strike a balance between TypeScript and Angular 2. So that's where we draw the line. So now we're getting into Angular 2. Question now is, how do I install Angular 2? It's all a bunch of JavaScript code. So one of the ways is to use the Node package manager, and I have given you a sample package.json file. So if you're not familiar with NPM, if you're not familiar with Node.js, I strongly recommend getting just enough understanding about how the Node packages work. How do I define a package? How does the package.json file look like? How do I declare dependencies? Get an understanding about that, because there is no way you can avoid these days using NPM and Node for the development time. We're not talking about using Node as the server runtime. Your server can be Java, could be Scala, .NET, whatnot, doesn't matter. But the development activity itself is more and more regulated by Node. So it's good to have that skill built up. So the first line in the dependencies section is the most important one. This is where you're pulling in Angular 2. At this point, Angular 2 requires a whole bunch of other. I talked about the System.js. System.js, it gives us the ability to bring in a module into an HTML page. So there are a whole bunch of other libraries that you need. We need them mainly because our browsers are not compatible to ES6 yet, and it's not going to be for a while. So there's a lot of missing pieces that Angular needs and depends on. Someday when the browsers support ES6, all of these libraries will go away. We don't need them. We can just use Angular 2 in that case. But that's not going to happen for a while. So until that happens, we're going to require all of these polyfills, if you want to call them, or libraries that fill in the blanks, fill in the missing pieces. So I have listed them all. One thing I do not really like about this is that if Angular 2 really needs these, it should declare them as dependencies, and we shouldn't have to deal with them. NPM knows the dependency hierarchy. So ideally, all we had to do was bring in Angular 2, and that Angular 2 should bring in anything else it depends on. We shouldn't have to worry about that. Unfortunately, it's not done that way for whatever reason. We have to be aware of Angular 2's dependencies, including the version numbers and so on, like I've shown here. And it's not a perfect world. We have to live with this for now. All right. So I said earlier that the biggest news about Angular 2 is something called a component. So let's spend a little bit of time understanding what a component is and finally how to develop one. So component is a self-sufficient artifact, code artifact, that can implement an entire functionality, whatever that is. So the entire functionality is developed by a single piece of artifact, and that can be added to a page with just a tag without doing any further programming. Okay, so that distinguishes, the component is distinguished from an Angular 1 controller, for example. With the Angular 1 controller, you still have to have a lot of HTML template code that the controller was managing. All right, so as a result, controllers in Angular 1 was never meant to be reusable. Controllers are not reusable in Angular 1. By the simple fact that controllers are not injectable in Angular 1. You could not use one controller from another controller. They're not inheritable, they're not injectable. Controllers were the end consumer of everything else you developed, like a directive or filter or service and whatnot. A controller themselves could not be reused. By contrast, components are usable because when you use a component in a page, all you are doing is adding the tag for the component in the page. There is no additional coding required. So what do components do? It presents data to the user using HTML. It can also handle user interaction events. All right, so let's take a look at two examples here of components. The first one is a product display component that shows an image for the product. It shows the price, and there's also a button called Add to Cart. When I click on the button, the component is responsible for adding that item to my cart. And all of this we get by adding a simple tag into my HTML page. You don't have to know how it works and none of these details. And I can add that tag to any page in my application. Then I'll have a product display page. Fully functional product display, including the ability to add to cart. I have a second example, which is what we'll be developing in the next few slides, which is email subscription. All you're doing here is you're typing in your email address and you're clicking on subscribe, and then you're subscribing to a newsletter. And once again, we're going to be adding this using a single tag, and I can do that to any number of HTML pages, any number of times, and it's going to show up in my page. And now, some of you who are Angular 1 developers and have done some advanced programming there, this might look familiar to you. In Angular 1, this could be done if you combined a directive with a controller. In Angular 1, a directive can have its own private controller. So they can work together with each other. So this component business could be replicated in Angular 1 by combining a controller with a directive. I don't want to go into too much details, but it is possible. The concept of components was also there in Angular 1, but it was not very well highlighted. And I think only the most advanced programmers use that usefully. Whatever that is, right now in Angular 2, component is the default way, the de facto way of approaching solving a problem. So let's see how this works. We're going to define a component. First, we write the code for it. So we import the Angular, from the Angular library, we are importing the component. So we have seen how import works before, nothing new here. So we're importing the component, and component is not a class, it's not a function. What it is, component is a decoration. Okay. So Java or C#, they all have these decorators. So basically, we have a class called export class subscribe newsletter. That looks like a plain class. But what we have done is that we have decorated this class using @ component. So a decorator basically attaches metadata to a class. So what metadata we are attaching to our class? We are saying that the selector is subscribed. The selector is nothing other than the tag name that we will be using at the end of the day to use our component or add our component to a page. That's the tag we'll be using. So in our case, it's subscribe. And then we have a template URL. So the HTML for our component is defined in this HTML file. So you have taken care of those two things. All that is left to do now is to manage the state. So in our, if you look back at our screenshot for our email subscription component, we need to be able to accept users' email address as input, and should be able to handle the subscribe button click. So corresponding to that, our component has a state variable called email, which is of type string, and we have a method called register email, which we're going to hook up with the button. So when you click on the button, that method is going to be called. So the only thing new here is the decoration of the class using the @ component, and all we are doing is we're specifying the tag name and the location of the template HTML. So let's take a look at the template HTML file. So it has, it's a plain HTML, and then you have an input tag, and there we see some Angular magic here. It's shown in boldface. That's basically binding the email field of the component to this input box. So it's the same two-way binding that we have seen in Angular 1. Nothing new here, except the syntax has changed. And then for the button, we have the click event. And once again, we are binding the method register email to the click event of the subscribe button. Very similar to Angular 1, except the syntax is different. Finally, we create a main.ts file, which imports all the components that you're going to be using. And we are bootstrapping our component, meaning this component code will be loaded. And basically that starts off, the bootstrapping process starts off the whole compile phase. The Angular starts to parse your DOM and looks for Angular attributes and starts to compile the DOM. So we do that from the main.ts file. So now all you have to do is bring in main.ts into our HTML file. So how do I add a component to a page? Once again, the process is a little bit more elaborate right now. So if you look at the script tags in my HTML file, I have the last line, which is Angular 2, which is basically all we need. Unfortunately, Angular 2 requires a whole bunch of other modules because the browsers don't have proper support for ES6. And we have seen them in our package.json file. We have installed them. So we have to bring them into our HTML as well. So you have to manually add them one by one in this order into our HTML file. Okay. So it is a bit painful, but you have to live with this for now. So go to the next slide. We still haven't brought in the main.ts module. So here we use the system import API I showed you earlier. And then we import our main.ts module here. So that's the only application code file that we're referring to from HTML. You don't have to worry about the rest because the rest of the JavaScript files will be automatically pulled in because of the module dependency. That's the advantage I was talking about earlier. And in a large, complicated project, this helps out a lot. And finally, within our HTML page, we use the tag, which, if you recall, we called it subscribe. So we simply add the subscribe tag here, and when the page runs, when you bring it into the browser, you're going to see the component show up. And you can add this component as many times as you want. And in each case, it's going to instantiate a new component object, and so that the state can be managed separately for every occurrence of the component in the page. Right? So using the component is super easy compared to controllers, where if you wanted to use a controller from another page, you pretty much have to copy and paste all the HTML template. That's not very useful. All right, so that shows you how to create a component. Hope it was useful. Again, if you have questions, please ask. And I'm going to move on to service and dependency injection. So in Angular 1, first of all, services, what are services? When I say services, I mean the artifacts in AngularJS that have business logic code, pure business logic code, irrespective of the GUI. Services don't manage GUI in any way. They don't handle user input events. They don't render any data. They don't deal with fonts, styles, and none of that. They have pure business logic that is devoid of any kind of user interface considerations. So there's different ways of creating services in Angular 1. There are providers, there are services, there are factories. They all did similar things, and defining any one of them was a bit awkward. So all of that is gone. A service in Angular 2 is a plain old class, ES6 class. There's nothing special about them. They don't even need any decoration like I showed you for a component. It's just a plain class. So here we are defining a service called register service. So when user enters the email address and clicks on register, eventually this service will be responsible for subscribing the username or adding the email address to the database. So for the, once again, the keywords, the export and class should be fairly obvious to you by now. These are ES6 keywords to define a class. And we are adding a method called subscribe, which takes an email address, string email as an input. And in this case, we have very simple logic. We're simply logging the email address. In real life, you're probably going to be making a web service call, calling a web service to add the user to the database. But that's all there is to it, to a service. And rightfully, it was just too easy. All right, how do I use the service from our component? Once again, we bring in our service module into scope using import. And to our component metadata, we add providers. Providers are basically an array of class names that are injectable. So by stating the providers, we are saying that these are the classes I intend to inject into this component. And then in our component constructor, I use an argument of that type. So here our constructor has a parameter called SVC of type register service, and it is at the constructor level that the injection happens at runtime. So the Angular magic comes into play here, and when the component is created, the input argument will be injected by Angular. Just like in Angular 1, by the way, the service is a singleton. So only a single instance of the service will be created, no matter how many times it's injected within a page. So now the component has to save it. So I have a member field called register service where I'm saving the injected value of the service instance so I can use it later on. So now my register email method, which is hooked up to the button, is offloading the work to the service, is asking the service to subscribe to this email address. All right, so that shows kind of the best practices of how to separate the component from the service layer and how the injection takes place. So again, not to belabor the point, but notice how the dependency is getting built. I don't have to include register service.js from the HTML file. I don't have to know about what else I need. The HTML file only includes one JS file. Everything else gets pulled in on demand. Okay, so I think that's the end of our presentation. Thank you again for sitting through the presentation. I hope it was useful. Please feel free to ask any question. and I'll be happy to answer your questions. I'll be here for another 10 minutes or so. I have a question here that says, how do you avoid tag name collision among modules? Component selector names, that is a good question. It is possible that you might have two modules, two components coming from two different modules that are using the same tag name. That will be quite unfortunate. Actually, I don't have a good answer for that. Never thought about it until now. So I'll find that out. I don't know how to get back to you, but it is a good question. I have another good question here. Is there a tool to migrate existing 1.x to 2? There, the story is quite interesting, and I like the way Google is approaching this. There is a ng migrate module that comes as an optional download for Angular 2. It's called ng migrate. Take a look at that. What ng migrate lets you do is that you can start to use Angular 2 in an existing Angular 1 project. So they can coexist in the same project. So for example, you have an existing project that's using Angular 1. All new features can then be developed using Angular 2. So you can do a gradual migration. So both of them are being used at the same time. Your old features are done in Angular 1. New features are done in Angular 2. And then slowly and optionally, you can go ahead and convert your Angular 1 code into Angular 2 piece by piece if you need to. So I think that's a pretty good story. Otherwise, there is no magic bullet. There is no way to translate your Angular code into Angular 2. Question is, would you recommend waiting until Angular 2 is out of beta before using it in a production project? I think Angular 2 is getting pretty close to release right now. My expectation is that it's going to be released pretty much any day. I don't anticipate a lot of changes. If you look at my package.json, some of the version numbers will change for sure. Keep an eye out for that, and Angular 2 website does a pretty good job keeping the version numbers up to date. But as such, the framework itself is not going to see any major changes. I believe there is a major company out there that are using Angular 2 right now. The name escapes my mind. It's a fairly, not Netflix, but it's a fairly well-known company out there. They're already using Angular 2 in production. So I think if you are thinking about using Angular 2, you can get started. The benefits will definitely be, is going to outweigh any disadvantages. And again, the big changes you might have to do is just change the package.json, the version numbers of different modules have to be updated. The code itself, I don't think you're going to have to update the code much. I have another question here. Could you give us a use case of using server-side script in AngularJS 2 as opposed to 1.x? I'm not sure if I understand it correctly, but server-side rendering is a new feature in Angular 2. This did not exist in Angular 1. So let's say that your server side is Java, for example, Java EE or Spring and whatnot. There are some special libraries that you can download from Angular 2 and you can use those libraries to pre-render your AngularJS pages. So the server responds with already compiled and rendered HTML. So the initial rendering doesn't have to happen in the client side. So that speeds up performance, and of course the crawlers, the search engine crawlers are going to find the content already there. So that's a new thing in Angular 2. I'm not sure if I can compare this with Angular 1 in any way. Next question. Is there any sample Angular 2 project that you can recommend to get us started with? If you go to the Angular 2 website, they have a tutorial that they're keeping on adding to it. It's called the Heroes website. It's basically a database of superheroes and their capabilities. It's quite funny, and you can definitely use that. It's well documented. You can follow through with it, and they're keeping on adding more and more advanced features to it. So you can start slow and easy, and then learn about the more advanced aspects of it. And there are step-by-step, very well-written guide to it. I highly recommend. If you're learning Angular, that's the first place I'll start. It's called the Heroes project. It's obviously linked in from Angular 2 website. Yeah, again, I just question is why choose server-side? I gave you the rationale behind it. The two main reasons for server-side rendering is search engine optimization and performance. So if you are doing a lot of heavy-duty rendering, and remember, not all clients and users have powerful machines. They're not running all 16 gigabytes of MacBook Pro and whatnot. So if you're doing heavy-duty rendering, it might be faster to do that, especially for mobile browsers, by the way. Especially for mobile browsers, it makes sense to do the initial rendering in the server side and do more and more rendering in the server side, and so that it shows up faster. So you have to do some testing for your targeted client audience. You know, if it's a mobile user, what percentage of users are using old Android phones versus new iPhones, and even then, what is the weight of your pages? So you got to do some experimentation and see if it makes sense. If you see a considerable performance improvement by doing rendering in the server side, it's an optimization thing, and you can use that as a tool.